So now we will discuss over the next topic, that is your number system, right? Number system, codes and data representation, how you can represent your numbers in form of 1's complement, 2's complement, right? So all these things we will discuss in this lecture. So you all know there are only two type of numbers, positive number or the negative numbers, right? So these positive numbers and the negative numbers are represented by three types. One is your sign magnitude, second one is your 1's complement. Maybe some of you are familiar with this complement, 1's complement, 2's complement, 7's complement and so on, right? 2's complement. So this positive number and the negative numbers are represented by three methods. One is your sign magnitude, second one is your 1's complement and the 2's complement, right? So now this is any number and this is its, this r is sometimes it is called the radix or it is called the base of this number, right? If this base is 2, right, that is called which type of number? That is called the binary number. If this base is 10, it is which number? Decimal. If this base is 8, then it is called the octal number, right? So if we can say, if this number or we can say this r is 2, then it is called the binary number. And what are the digits for this? If the r is 2, possible digits, it may be 0, may be 1, right? If it is 8, then it is called the octal. And what are the different digits? 0, 1 up to 7, right? If it is 10, then it is called the decimal and the possible digits are up to 9, right? If it is 16, then it is called the hexadecimal, right? And what are the possible digits? 0 to 9, and after 9 it is A. A is 10 is represented by A in the hexadecimal, then B, C, D, E, F, right? Here this 10 is represented by A, B, 12 by C, 13D, 14E and 15 by the F. This is your hexadecimal representation, right? If this base is 6, then what are the possible digits? 0 to 5, right? And so on. If it is 13, then 0 to 9, then A, C, right? This is the representation of these bases, right? Now, we will study the conversion from one base to other base, right? Or we can say, how you convert. First is, we will convert the decimal to other. How you can convert one decimal number, that is, for example, x0, x1, x2, this is dot y1, y2. This is in decimal form. How you can convert this to other any form? We have to use the division and multiplication method, right? So the division we have to apply before this dot, right? For the fractional part, you have to apply the multiplication. Clear? So for example, I am taking one number that is 23.125. This is in the decimal. How you can convert this number to the base 2 or binary? So before this 23 we will apply the division method. We will divide this 23 with 2 or to any base. Suppose you want to convert this to the octal, then we have to divide this 23 with 8, right? So here we have to convert this with the binary. So we have to divide this number 23, right? This left hand side number 23 with the 2, right? So what is the remainder? Remainder is 1. Again you have to divide 11 with 2. What is the remainder? 1. Now remainder is 1. You have to divide up to, we will get the remainder 0, right? So this is what? 2, 1, right? What is the remainder? 0, right? So we have to write in this way, in this direction, right? So the binary of 23 is 1, 0, 1, 1, 1, right? This is binary for 23, right? Similarly, what is the binary for this fractional part? We have to apply the multiplication here. We can multiply this 0.125 with the r. Here the r is 2, right? So we have to multiply it with the 2, right? So what is the, it comes 0.250, right? So we have to take this thing only, right? This left hand side we have to take. Now again this is 0, right? So again we have to multiply this 25 with again 2. We will get what? 0.5. Again we have to multiply it with 2. What we will get? We will get 1.0, right? And this is the end of this multiplication method, right? Up to we'll get 1.0. Clear? So the total, the binary of 23.125 is 10111 dot, first this 0, then this 0, then this 1, right? This is the binary of this decimal number. In this way we can convert decimal to any other base, right? So we'll take the second example to convert to the base 8, right? How you can convert? Similarly, 37, for 37 use the divide method, right? You have to divide it with the 8 because you have to convert this decimal to the octal, right? So 37 divided for 8, divide by 8, it comes 4. What is the remainder here? 5, right? Remainder is 5. So now can you tell me this 4 is divided by 8 or not? No, it is less than its base. So our answer is this, in this direction, right? So 37 is represented in form of octal, 45 8, right? This is only for the 37. Now this fractional part, right? So the fractional part is 0.625. Clear? So 0.625, how you can convert 0.625 into 8, right? 0.625 multiply 8, 5, right? So this 5 is less than 8, right? So our aim is to find the this thing which is less than 8, to find here in the form of for the division method, to find the remainder which is less than that base for which you have to convert, right? So here this is 5, so here directly we can write down 45.5. This is in form of octal. So like this you can convert any number to any decimal to any other base, right? So in the next example you can convert to the base 16. Similarly, you have to divide 37 with the 16, right? And directly I am writing here the answer. It will come 25.A, right? So if we multiply 0.625 with the 16, right? So what is the answer? Answer should be this. And what is this? What is this 10? In form of hexadecimal. 10 is represented by A. So in this way we can convert any decimal to other number, right? Now we will discuss our next category, that is your others to the decimal, means in the reverse way. Others number to decimal. Suppose this is your number, suppose this is any base number and you have to convert to base 10, right? How you can convert this thing? So for this you have to, this is R0, right? Suppose you have to convert, this is in the base R, right? So this is R0. This position is R1. You know this position is R2. And this position is R minus 1. This position is R minus 2, right? So for this, you have to multiply this R0 with X0 plus R1 with X1 plus R2 with X2, right? Then plus X minus 1 with R minus 1 plus X minus 2 with R minus 2 and so on, right? This is the way here to convert other numbers to the decimal method, right? So we can take some examples here. So for examples, first we have to convert the binary to the decimal, right? Previously what we have done. So suppose this is your any binary number, you have to convert this number to the decimal, to the base 10, right? So you know this is which position in the binary, 2 to power 0, this is 2 to power 1, this is 2 to power 2, this is 2 to power 3, this is 2 to power 4, and this is 2 to power minus 1, this is 2 to power minus 2, right? So we can easily convert this to decimal, clear? So here 2 to power 0 multiply with 1, 2 to power 1 multiply with 1 and 0. If you multiply 2 to power 2 with 0, it will comes 0. So you can directly put here 0. Now 2 to power 4 multiply with 1, right? Plus 1 into 2 to power minus 1 plus 1 into 2 to power minus 2, right? So if you solve this calculation, then it will come 19.75, right? So this is your decimal number of this binary. Clear this method? How you can convert other number to the decimal? Clear the thing? Now we can take one more example. How you can convert this octal to base 10, right? Here. Now the next example we can take in this category. How you can convert, this is the BAD, right? It is in the hexadecimal, right? So you have to convert this hexadecimal to the decimal. So in the similar way, what is this position? This is 16 to power 0. 16 to the power 0 multiply with D. D is your what? What is D? D is basically 30, right? Next is B. Sorry, A. Next, A is your 10. Now, what is B? This is your 11. So, if you solve this thing, then the answer is 2989. Right? So, in this way, you can convert your other numbers to the decimal. Now, one question that comes into the previous GATE exam. This type of indirect questions will be asked in your exam, right? So, square root of 41 to the base B. What is the value of B? What is the value of B? So, to find this value of B, it is clearly seen. First, you have to solve the square root of 41, right? So, if you take the square on both sides, so now this becomes 41B and this is your 2510. How you can convert other numbers to the decimal? You know, b to power 0 multiply with 1 plus b to power 1 multiply with what? 4, which is equal to what? 25. This is b to power 0 is your what? 1. 4b is 25 and b is your what? 6. This is the answer. Clear? So in this way, you can solve this type of questions, right? Now our third category is convert octal to the binary. So this type of circuits that converts octal to the binary is called the encoder, right? So in the details about this encoder we will discuss in the next unit, that is your combinational circuit, right? So those circuits which converts any octal number to the binary numbers are called the encoders, right? So in this category basically each octal digit, if you convert octal to the binary, then each octal digit you have to show, you can shown by 3-bit binary, right? 3-bit binary. For example, what is the maximum number for the octal maximum digit that can be represented by in octal? 0 to, so 0 can be represented in form of binary by 1 can be represented in form of binary, right? And up to 7, how 7 can be represented in form of binary if it is octal? 1 1, right? Clear? So that's why each octal digits you have to show, you can show with 3-bit binary. Clear the thing, right? So for example, if I am directly asked how you can convert this to the binary, one big method is, lengthy method is, first convert this octal to the decimal, then decimal to the binary, right? That is time consuming method. So that's why each octal digits you can represent with 3-bit binary, right? So for example, here this is 375. So how 3 can be represented in form of binary? 3 0 1 1. How 7 can be represented by the binary? 1 1 1. How the 5 can be represented? 1 0 1. How the 4 can be represented? 0 0. And how the 2 can be represented? 0 1 0. Right? This is the binary of this octal. Clear? So the next category is binary to the octal in the reverse way. How you can convert? The circuit which converts the circuit which converts any binary number to the octal is called the decoder. Clear? So here we can make the group of 3 bits. Group of 3 bits is your what? One octal digit, right? One octal digit. Clear? For similar example, if we are saying convert this number to the octal number, how you can convert? Make a group of 3 digits, start from here, this one, this one, this one, right? So this is your what? Which number? 5. This is what? 7. This is 3. Clear? So in some cases, for example, this is the number. What you will do in that case? Start from here, LSB, then here is only 2 digits, then what you will, yeah, you can add the 0, right? Clear? So now it is 175. Clear the thing? In this way you can convert the binary to the octal, right? Also the next category is hexadecimal to the binary. The circuits which convert hexadecimal to the binary also called the encoder, means any circuit that converts other codes to the binary code is called the encoder. Clear? And the circuit which converts binary to the other codes is called the decoder. Clear? So hex to the binary, it means each hex digit, each hex digit is combination of how many binary digits? 4-bit binary, right? This is the method to convert hexadecimal to the binary. And in the 6th category, opposite, binary to the hexadecimal. Each or a group of 4 bits, is your what? One hex digit. Okay. So the next category is how you can convert hexadecimal to the octal. How you can convert hexadecimal to the octal? First you convert the hex to the binary and then to the octal, right? This is all about the conversion. You can convert now any type of base to the any type of base. You can easily convert, right? Now, or the next thing is arithmetic operations. For the binary, you can do addition, subtraction, multiplication, right? So the circuit used to add the binary digits is called the adder. The circuit used to subtract two digits is called the subtractor, and the circuit which is used to multiply two binary digits or more than two binary digits is called the multiplier, right? So the group of 4 bits is called the nibble, right? Maybe you all know this thing, I already told you. Nibble, group of 4 bits, right? And group of 8 bits is called what? Your byte. Clear? Clear? So now addition of 0 plus 0. What is this? 0, 0 plus 1. Addition. 0 plus 1. It is 1. Now 1 plus 1. What is the addition? Sum is 0. 1 plus 1. Sum is 0 and carry is 1. Right? This is the 1 plus sum. Right? This one is your carry. Sum is 0. Right? Clear the thing? Now, what is your 1 plus 0? 1, right? So So what is this 1 plus 1 plus 1? 1 is sum and 1 is again carry. Clear? So like this you can add more the bits, right? For example, yeah. For example, so here the example is, this is your one number, this is your second number. How you can add these two binary numbers? 1 plus 1. This is 0 and carry is 1, right? So again 1 plus 0 plus 1. This is 0 and again carry is 1, right? 1 plus 1 plus 1. 1 carry is 1. 1 plus 1. 0 carry is 1. 1 plus 1 plus 1. 1 carry is 1, right? So this is your binary addition. Clear? Now next example we will take the binary subtraction. Subtract this number from this number. Now tell me 0 minus 1. You have to take the borrow. Borrow. If you take the borrow from here, from the this digit from here, if you take the borrow means here 1 is not taken. If you are taken from here from the borrow, then means 2 comes here, right? This position means 2, right? So now 2 minus 1. This is the way, right? 2 minus 1, 1. This is the way for the subtraction. Now here remaining is, you already taken this 1. Here this 1 is equivalent to 2, right? Clear? So now here remains the 0. So 0 minus 0 is 0. Now again 0 minus 1. Again you have to take one borrow, right? It becomes 2. 2 minus 1. And here 0 minus 0. And this 1 minus 1. 1 minus 1. 0. Clear? This is the answer. Or this is your binary subtraction. So similarly, you can do the binary multiplication. Third example we can take for the binary multiplication. What is the answer? How you can multiply 1101 with 1011? Similar normal multiplication. First, this digit is multiplied by the whole this number. What is if 1 multiply with 1? 1 multiply with 0. 0, 1, 1. Now, similar to the normal multiplication, leave this digit, right? Now, 1 multiply with again, it comes 1, 0, 1, 1. Now, leave the two digits, this first blank, then 0 multiply with this number, it comes 0, all 4 its positions 0. Now, again, multiply this 1 with this number, it comes 1, 0, 1, 1, and the addition now. Now, 1. Now 1 plus 0, 1. 1 plus 0 plus 0, 1. 1 plus 1 plus 1, 1. And here the carry also 1, right? 1 plus 1, 0 carry 1, right? 1 plus 1, 0 carry 1, 1 plus 1, 0 carry, right? This is your binary multiplication. Clear? So we can say your n bit multiply with the n bit, it will give you the 2n bit, right? Here this is 4 bits multiply with 4 and 4, it will give the 2n, means the 8. Clear the thing? Now the octal addition. Second category in this is the octal, right? So in the octal, what is 1 plus 1? You know the octal bits, what is the range? 0 to the 7, right? So now 1 plus 1 is what? 2. Normal addition. 1 plus 2 is 3. So on. What is 1 plus 7? What is the equivalent? What is 8 in the decimal now? What is the this equivalent octal number of 1, right? So 1 plus 7 is 1 0, right? Now 2 plus 7. This is 9 basically in form of decimal. And what is the equivalent octal of 9? 1, right? And so on. Like this, you can do the addition of the octal number. What is 7 plus 7? 14. 14 in the decimal. And what is the equivalent octal of the 14? 1 6. Right? Clear? So in this way, you can do the octal addition. For example, so just a minute, I am giving little bit complex number 7652. Yes, now it is in the octal, and again 4315. Right. Now add these two octal numbers. 5 plus 2, 6. Now tell me 6 plus 3, 1, and 1 again. Now tell me 7 plus 1, 8, plus 1, 1, right? 0. Also convert the thing. Got it? Right? So now you can convert all this, or you can add your these octal numbers. Now the question is how you can subtract these octals, right? Similar to the binary subtraction, right? Similarly, you can subtract two octal numbers. So the example is 7435. Subtract this number from 7, right? Now tell me 5 minus 2. What is the answer? 5 minus 2. It is 3. Now, can 4 can be subtracted from 3? No, we have to take the what? Borrow, right? And we have to take the borrow from this position, right? And if you take one borrow, then what is here? It is 1. 1 will add or 8 will add? 8, right? Because it is the octal number, right? If you take one borrow from this octal position, then we have to take 8. So 8 plus 3, what is it? 11. 11 minus 4. 11 minus 4. 7. Right? And here the remaining one is 3. Right? Can be, can be subtracted from 3? No. Again we have to take the borrow. Then 8 plus 3 is 11 minus 6. 5. Right? And here the remaining one is 6. 6 minus 2. Right? So this is your octal subtraction. Suppose you are saying this number should be less than this thing, right? Okay, so that thing we will study in the next section. That is your that answer can be represented or can be solved only using the 1s or the 2s complement, right? Because here this is sign, this is without this, all should be like positive things, right? So the negative numbers can be represented by 1s complement and the 2s complement. In that case, your answer also should be negative in that case, right? So that thing we will discuss when we will discuss about the 1s and the 2s complement. Okay. Now in the similar way, you can do the hexadecimal addition and the subtraction, right? So we can take some examples of hexadecimal also. So in the hexadecimal, suppose we are saying a plus a. Now tell me, a plus a in decimal it is 20, and how you can represent 20 in the hexadecimal? Divide by 60. 1 4, right? we are directly representing this 1 and the 4, right? This is not 14, this is 1. So this is not E, this is 1 4. Okay, this is not 14. Please remember here, don't get confused. It is not 14, it is 1 4. Okay, clear? Okay, so 1 plus 1, A plus A is your 1 4, not 14. Remember this thing, don't get confused here, right? So we can take some examples here. 9653, this is in the hexadecimal. Also the 7 6, both are in the hexadecimal, right? So what is the solution? 3 plus 2 is your what? What is 5 plus 6? B, right? And what is 6 plus 7? D. What is 9 plus 8? Yes, 1. Okay, clear? This is 1 1. So don't try this 11B. Okay, this is 1 1. Okay, clear? This is 1 1. Right? So one example we can take of the subtraction. Similar example 8 7 6 3 2 5 7 8. Right? So now both are your hexadecimal. Now subtract this number from this. So what is 3 minus 8? You have to take what? Borrow. So if you take the borrow from here, it will come 16. Now 16 plus 30 is 19 minus 8. Now the remaining one is 5, right? So 5 minus 7 is not possible. So you have to take again one borrow. So now 16 plus 5 minus 7. 16 plus 5 minus 7, it will come 14 for the E, right? And here the remaining is 6. 6 minus 5 is 1 and 8 minus 2 is 6, right? So this is your answer. In this way, you can do the addition, subtraction of these binary numbers, decimal numbers, octal numbers, or the hexadecimal numbers, right? So this is all about the today lecture. In the next lecture, we will discuss about the complement, right? How you can find the 1s complement, how you can find the 2s complement, and how you can represent your numbers in form of 1s complement, 2s complement, right? So students, if you have any doubt related to this topic, then you can send me a mail or you can contact me directly. So for more video update, please subscribe this channel, fine, so that every information regarding your course or regarding this digital electronics lectures you can get easily, fine. Thank you for your attention.